Hello, welcome back to my bench. Today we have another older piece of radio gear. This is called a TFT AM monitor, and it monitors my radio stations for AM modulation and make sure that we don't go over 100% positive and 125%, no, 100% positive, 125% negative, no, other way around, 125% positive. Anyway, and it's not working correctly. This one has been worked on before, as you can see. Well, maybe you can, but in here there's some signs that the capacitors have been replaced, which they have, but our problem right now is I am feeding this with about a 0 dB level, 920 kilohertz, my radio station, and about a 0 dB level of AM audio. And I'll show you a picture. Here's the audio meter, and it's got nothing on it. There's my settings. You can see right here I have the correct level of RF. I'm on 0 dB for the modulation meter, and it's in negative modulation mode to measure, and it's not showing anything. That should be, oh, let's see here, right, okay, there we go. Right there, it's not showing anything, and that should be up, oh, around there someplace. With what I'm feeding into it. I'll show you what I'm feeding into it. It's right there. Yeah, that's about right. And there's my frequency, which really doesn't make any difference. This thing will go from about 0.5 to 4 megahertz. So, anyway, what's the problem? Don't know yet. We'll take a look at the schematic here and see what we got. Well, first of all, I'll tell you what, let's take a look at the, where is it? Somewhere in the mess of papers. Here they are. We've got a function diagram of how this thing works. Alright, so basically what we got here, RF of your frequency, whatever your frequency is, comes in over here, goes through an AM detector, normally, or unless you got it up in the calibrate, it goes up there, but we're not worried about that. It goes through an AM detector, linear phase and low pass filter, audio attenuator, which is basically a voltage controlled audio attenuator, and a buffer amp. Then it comes down through here. Part of it goes through the 125% detector light, the 100% detector light, and the peak detector LED. All of these are working. The only thing that's not working is the meter. So it's got to be down here, either in the meter amp, the 0 to 50 dB attenuator, or the 50 dB amplifier, or the meter detector. So we'll find out what's going on. At least that's what I'm thinking at this point. And the schematic, where is it? There's a front panel meter, modulation meter, and it goes back through here to a 741, which is Z22, and it's driven by Z21, which is an 801. Both of these just little old single op amps, nothing to them. So we're going to take a look and see what we can see. Let's start off here on the output of Z22. Let's see what it says. Where's Z22? I'll tell you what, first thing we do, measure voltages. You can get yourself in trouble if you don't measure voltages. So what do we got? here's Z21. Let's try this. So it's pin 4. We've got 12.1 volts. And then on these guys, pin 7 is it's 12 volts also. So we've got the correct voltages according to this. Plus or minus 12 volts driving that thing. Minus 12 on pin 4. And plus 12 on pin 6. So that's right. Next one up is the 741, which is Z22, which I presume is here. So there's pin 7, 11.99, 12 volts. And here is pin 4, 12 volts negative. So that's correct. Alright, so now let's take a look at the input is pins 2 and 3. With a scope, and then pin 6. Okay. Get the other camera going here. Wow, that's kind of bad. All right. Let's see if I can do this. Here is pin 6 of Z21. That's the output. So we've got a good output coming out of there. Their next one is the diode. There is, I got a voltage going into the diode, but actually I've got coming out. There's my sine wave going into the detector diode. Sine coming out of the detector diode, I've got a good voltage. I don't know what it is. Let's see, 0.2. So it's 0.2, about 0.4 volts. Then on pin 2, which would be on pin 3, which is the positive input of that 741, we got 0.4 volts going in. And coming out of, on pin 6, I've got a lot of negative. Wow, negative voltage. What? Let's see, let's take this up to 1 volt. See what we got. Sorry about the camera, I ain't got nothing to hold it with. So, we're talking about negative 1 volt. Oh, okay, that's not right. Because the meter, okay, turn this off. Alright, so the meter is driven positive or negative. Meter is driven positive on the positive side, so the meter should have a positive voltage. So what I got going into the op amp, volts wise, I'm not going to hold the camera up here for this. I've got on pin 2 of that 741, I have 10.66 volts on pin 2, which is the negative input, and I've got 4.17 volts, which is the positive input of that Z41, or that 741, which is coming back, so that's a negative. Ooh. Alright, so I've got a good drive going in on pin 2, but I've got a massive amount of negative voltage coming off of back through it. I'd say that 741 is wrong, because remember, it's in a op amp like this, it's going to do its darndest to try to make the positive and negative inputs the same, and they're not. So we're going to say, turn it off, I'm going to say this guy over here is bad. So let's see, let's just so you can see what I'm doing here. There is, right here is the little op amp in question. Isn't that an interesting shot? Okay. And we're going to take that out. It's a 741 single op amp. Wow, kind of stuck in there. I don't have any 741 single op amps. However, I do have, I believe, up here, think these, yeah, there's a TLO 71, which is the same output as the 741, or the same inputs and outputs. Pinouts are the same. There's the dot. So let us push that down in there. Well, those are some really crappy connectors. These things weren't cheap. Okay. Alright, so here we go. We'll turn on the power. Let's make sure we get this going. Alright, there we go. Here comes power on. Boink. Aha! Cool. It works. We still got it settling down. Negative and positive should be identical at this point because it's just a straight sine wave going into this thing. So let's turn it up a little. And it's responding. Beautiful. Look over here at the lights. Yeah. Peak comes on just slightly before the 100%. And we are dead on 100%. Beautiful. Nice. And the peak is on here. Make sure that thing didn't screw anything up is what I want to make sure. So let's see, take 100. 100%. Light's not on. It's not above 100% yet, so let's try it again. Oh, there's your 100%. And there's the peak light. It's touchy, but it's working. So everything's working the way it should be. Cool. So that was easy. Wish I had one of Dave Jones's buttons. That was easy. Anyhow, there you go. Some repairs are not hard. Well, let's take a look inside this thing for a minute here. This is old through hole. It's basically pretty simple. You give it an input back here, which I'm using my old Hewlett-Packard, what is this thing? 8640B on 920 kilohertz. You feed a signal into it. It goes through its processing here like we went through on this little guy. Basically it amplifies it, it detects it, and it just goes straight off of voltages off of these op amps after the detectors. I don't know exactly the reason why it takes a 50 dB attenuator and then an amplifier. I might look that up, but that's basically, electronically, that's all there is to them. What they do have in the outputs, though, is they've got audio outputs back here. Show you. Back in this section, there's audio outputs, there's alarm outputs, so that you can have this thing close a contact for you with going to ground. It doesn't have any internally. It has boards that you can stick here that'll do that, but this doesn't have any. But it does give you a switch through a transistor, and basically turns on an external relay for your alarm to go off. It also has, back here in the back, it's got a fuse, a ground. It has balanced audio output for going to something else, to whatever you need for it to go to. It has 5 volts RMS straight output. I don't know what that would be used for, but whatever. It also has some other stuff that you can do over here which aren't in this one, but then the stuff that you worry about is a carrier alarm, so that you can turn on something. Your transmitter went down, which is over here. You got telemetry output, so it'll just swing something either in a computer or whatever. It's just a voltage output. Modulation alarm goes off if the modulation drops below a certain point. And then you got audio monitor out, which you can hook up to, and like in my case, I hook this up to my My other modulation drop, or audio absence of audio monitor, and that's the way it goes. I mean, the way it goes off and beeps like crazy if we lose our audio. Plus it has a remote meter panel where you can hook up an external remote meter panel someplace else for it. So basically that's all these things are. It's kind of a very fancy AM radio that actually does do audio also. So anyhow, that's... Oh, there we go. Oh, I thought it died. No, I pushed the button in. Anyway, there you go. There's a look at a TFT Technologies, Time and Frequency Technologies Incorporated AM modulation monitor that is about 35 years old. Let's see, can I find... yeah, actually it's older than that because all the chips in here are marked about 1978. Huh. 40 years old, almost exactly. So still working, still in service every day. Little problems, replace the caps and blown out ICs. Anyway, hey, thanks for watching. Give it a thumbs up if you like it, and don't forget to hit that subscribe button and the little heart down there, or the little thing, so that you get notifications when I'm doing something, and so you never miss any of this riveting stuff.